Remember, when multiplying exponents, the x to the third times x to the fourth really means x times x times x, because that's x to the third, times x to the fourth, x times x times x times x. So this was x to the third, and that's x to the fourth. And what that results in, there's 7 of them, so this results in x to the 7th. And so that's why the rule for multiplying exponents is to add the exponents. You keep the base and add the exponents. So the next one is x to the 11th, and this one is x to the 5th, because there's an invisible exponent of 1 on that x. There's one of them. And also, if you have a coefficient in front, like 3x to the second times 2x to the third, then the rule is to multiply the coefficients, keep the base, and add the exponents. So what this would result in 3 times 2, which is 6, keep the base of x, add the exponents, 5. Okay, with dividing exponents, if you think of this, x to the fourth as x times x times x times x over x to the third. So I'm just expanding these first to get an idea, and we can eliminate the x's that are stacked on top of each other, and so we end up with x over 1, or just x. So what's really happening is that you can just subtract the exponents. If you do 4 minus 3, you get 1, and it is x to the first. So the rule is to subtract the exponents. Keep the base, subtract the exponents. So x to the 6th over x to the 4th, we subtract, we get x to the 2nd. X to the 4th over, remember that's an x to the 1st, so we subtract, we get x to the 3rd. Again, if there's a coefficient, what we do is we divide the coefficient, so it's the same rule as multiplying. Divide the coefficient, keep the base, and subtract the exponents. And so what we end up with here, 4 over 8, well, that just simplifies to 1/2, so I'll leave it that way. And then x to the 7th minus, the x to the 7 minus 1 there is going to be x to the 6th, and that would remain on top because there was more of them up top, so we keep it that way. It makes sense if you write out 4 as like 2 times 2, the factor tree of 4, x, 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 over 8, which is 2 times 2 times 2, if you do a factor tree, times x. And you cancel some things, you'll see that we have x to the 6th up top, over 2. So you can write your answer that way as well. Okay, when we have what's called a power to a power, what this first example means is x to the 3rd times x to the 3rd, and we know that we add the exponents, 3 plus 3, so we get x to the 6th. So when we have a power to a power, what we're really doing is multiplying those, like 3 to the 2nd. Some people think of that sort of like distributive property. So that results in x to the 6th. So here, I could write out x to the 4th times x to the 4th times x to the 4th 5 times and calculate how many we'd have, or I can just multiply those powers. So it'd be x to the 20th and x to the 42nd. Okay, if we have in parentheses 3x squared to the 3rd power, I need you to understand that that 3 is going towards, because it's outside of the parentheses, it's going to the whole group, everything in the group. So it goes to the 3, it's really 3 to the 3rd times x squared to the 3rd. And so 3 to the 3rd is 27, and x squared to the 3rd, we would multiply those exponents, we'd get x to the 6th. Because remember, it would be 3x squared times 3x squared times 3x squared. So 3 times 3 times 3 is 27, and x squared times x squared times x squared, you add those exponents and you get x to the 6th.